we go. Third time's the charm. I had some technical difficulties trying to get this recorded for you, but I'm here. Ta-da! All right. So we're learning about exponents. And there are a lot of rules about exponents. And individually, none of the rules are very hard, but it's when you put them all together, they get all tangled up and they get hard to remember. So here's where we are. Quick review. So let's just start with, and if you forgive me, I do not have my touch screen for this one, so it's going to take me a little bit longer. If I have something like, let's say, 2x squared, and I'm going to add 5x squared to that, if I'm adding or subtracting, and if what I'm adding or subtracting is the same thing, so I have x squareds and I have x squared, that x squared is the same as a label. Like it's the same as if I said cats plus cats or dogs plus dogs. It's the same thing. So if I'm adding or subtracting, what I'm looking for is just, are these the same things? If these are the same things, then I have 2 of them over here and I have 5 of them over here. So I'm going to end up with 7 of whatever those things are. In this case, they're x squared. So I just need like things with like things. I'm going to combine them. So if I'm adding or subtracting, that is the case with that. If erase. Oh, this doesn't work on my computer. Hopefully I can do this. So I'm on a different computer recording this, so it's going to be a little bit different. All right, we'll make this work though. All right, so then that's if I'm adding or subtracting. But if I'm multiplying, let's change colors. I prefer a different color. All right, so what if I'm multiplying? What if I did the same thing? If I had that 2x squared and that 2x squared, let's say if I had the same exact things. But now instead of adding, let's say if I'm going to be multiplying them. So if you multiply coefficient times coefficient, so 2 times 2 is going to become 4 because I'm going to multiply the coefficients, just like I've always done before. And now if I'm multiplying exponents, when you multiply, you add, right? When you multiply, you add. So that becomes x, and this would be 2 plus 2. So I'm going to add the 2 plus 2, and I'm going to get the exponent of 4. So it becomes 4x to the 4th. So if I'm multiplying, multiply the coefficients, add the exponents. When you multiply, you add. I know there's a command to make this all erase. I got a dictionary. This is going to be a very interesting video by the time I'm done. All right, so that's multiplying. And then if I'm dividing, remember the rules for dividing? If you divide, you subtract, right? So if I have 4, let's say x to the 5th, and let's say that I have 2x squared, I'm going to divide those things. When I divide these just like you normally would. 4 divided by 2, right? 4 divided by 2 has always been 2, always has been, always will be. Just treat that like a normal thing that you would normally do. And then this part, if I'm dividing exponents, when you divide, you subtract. So it's x to the, it would be 5 minus 2, right? 5 minus 2. So that really is going to be 3. So instead of writing 5 minus 2, we write 3. So it's 2x cubed. 2x cubed would be our solution for that, all right? So if we're adding, we're looking for like things. If we're multiplying, we multiply the exponents. If we divide, we subtract. So if you multiply, you add. If you divide, you subtract. And then there was one more rule that we talked about called power to a power. And so power to a power, the rule is boom, multiply, right? Power to a power, boom, multiply. So if I have something like x squared, and I'm going to take that to the 3rd power, then my solution is going to be, or when I simplify that, becomes x to the 6th. So it's power to a power, boom, multiply. You're going to make it bigger, so it's 2 times 3. We're going to multiply those 2 exponents together. If I happen to have a 2 right here, if I happen to have a coefficient there, that exponent of 3 applies to the 2, and it applies to here. It gets applied to both. If they're inside the parentheses, it applies to both. So 2 cubed would be 2 times 2 times 2, which would be 8. So this would become 8x to the 6th because 2 cubed is 8. And x squared times x squared times x squared would be 2, 4, 6. It's x to the 6th. So power to a power, boom, multiply. All right? So that's a review of everything done before. So double check your notes, make sure you've got everything going on with that. So different keyboard. All right, so now let me just give you one more power to the power thing to kind of just put in your notes and just make sure you know. It doesn't come up very often, but I want you to see it and just put it in your notes. The difference between this, whoops, we have x squared cubed. Let's do squared. Do squared. The difference between that and this. These are two different things, and let's just kind of talk about those for a second. So notice what's different between the two things. What do you see that's different? Right? You see what you notice? Right? It's that negative, right? So here it's inside the parentheses, here it's outside the parentheses. So the difference is here, if you have a negative times a negative, it's going to be a positive. So this is going to become x to the fourth. It's going to be positive. Whereas this, the negative is going to keep it negative. So this is going to be negative x to the fourth. So this one, if the negative is outside the parentheses, it's going to be negative no matter what. Whereas this, it depends on what this exponent is. If it's even, then you have a negative times a negative. And a negative times a negative would be a positive, right? If this was an odd number, you'd have a negative times a positive times a negative, which is negative. So it kind of depends what the exponent is. So I just want to make a note of that. It doesn't come up very often, but I just wanted you to see it, note this. All right, so we have two more skills today. One is super, super easy, although you're going to mess it up. It's like super easy, but it is a commonly missed one. And the other one is a little bit tricky. This is very different from things that we see before. All right, so two, and this is it. And then we're done with all of our exponent rules. We just need to practice them until we get really good at them then, right? So this one is the power of 0. So let's see, I have y squared. Let's just start right off here. Just put y to the 0 power. Let's just start right there with basic, simple. So anything to the 0 power equals 1. So write that in your notes that anything to the 0 power equals 1. Doesn't matter what. Doesn't matter. If it's, as soon as you see that exponent of 0, your brain needs to not go 0, because that's the mistake you're going to make. It's like, oh, exponent of 0, it's 0. It doesn't equal 0. It equals 1. So, and if I had my tools and we were in school, I'd make it a lot easier to explain why that is. So when I see you in person, I will explain that. Remind me to explain that in person when I see you a little easier. So y to the 0 equals 1. And then so that could be literally anything. I could have like x squared, and I could have y cubed, and I can have z to the 9th. It doesn't matter. And if I take all of that and I put it to a 0 power, then it's going to equal 1. As soon as I see the exponent of 0, I'm like, boom, it's all gone. It's 1. It doesn't matter what's in parentheses. It doesn't matter what's around it. It automatically makes it 1. All right. And the last one, negative exponents. This is where we're going to spend most of our time today. This is the tricky one that I really want you to be able to see. So erase this. All right, negative exponents. So far when we've had a negative exponent, we've just left it where we found it. We haven't done anything with it. Well, today is the day that we make all negatives go away. Today is a positive day. Everything is going to be positive today. So if I have x to the negative 2, up until now we've just left it x to the negative 2, but no more negatives. We're going to make everything positive today. So that x to the negative 2, you need to realize that that is a numerator, right? That's really over an invisible. 1 is the denominator. So if it's negative in the numerator, it's positive in the denominator. If it's negative in the numerator, it's positive in the denominator. So it's going to flip, be the other way around. And we want to always write things in positive terms. We want to, if it's not positive here, we want to rewrite it in its positive form. So anytime, there will be no more negative exponents. If you get a solution, you get if you solve and you get to a negative exponent, you're not going to leave it negative. You're going to fix it so that it's always positive. So if you get an x to the negative 2, you're going to put x in the denominator, all right? Same thing as the other way around. If I get y over, let's say y to the negative 3, and that y is negative in the denominator, it's not happy in the denominator. It's going to move to the numerator, where it's going to be positive. So it wants to move to where it's going to be positive. So it's not positive in the denominator, it moves and becomes y to the 3. And that's really over 1. But remember, we don't write this over 1. We just write the y cubed. So 1 over y to the negative 3 equals y cubed. See how it works? All right, those are like the two basic ones. So if you have x to the negative 2, you get 1 over x squared. If you get 1 over y to the negative 3, it becomes y cubed. So you're just moving things. If they're not happy as numerator, you move into the denominator. If it's not happy if it's negative as a denominator, it's positive as a numerator. So you're just moving the negatives to turn them positive. All right, next level of that. Usually I can just hit Control Z and it erases my whole screen, but not today. Not today. This takes a little extra patience this way. That's okay. It seems lately have been all kinds of challenges have popped up and made things harder, but we can do hard things. We'll figure this out. All right. So we'll leave a little piece over there for right now. What if I have something like x to the negative 2? And let's say y to the 4th? And z to the, let's say negative 3. And now simplify that, right? We don't solve it because it doesn't have an equal sign to it. We're going to simplify that. So if I simplify that, I just want to make everything negative positive. So right now, these are all over 1. They all have an invisible 1. They're all in the numerator right now. Well, that x is negative in the numerator, but it will be positive in the denominator. So I'm going to move the x squared to the denominator. That y to the 4th, it's positive as a numerator. It's happy there. It's positive there. So we're going to leave that y to the 4th as a numerator. And that z, is it positive or negative? It's negative as a numerator, so it'll be positive as a denominator. So we would simplify this and rewrite it. So it would look like x to the 4th over y to the 4th divided by x squared z to the 3rd, right? So we're just sorting. We're just sorting. If it's negative as a numerator, we just move it to the denominator. If it's negative as a denominator, we're just moving it to the numerator. We're just like rearranging things, moving them where they're going to go. Make sense? All right, let's look at one more and then send you off to go do some practice. Got a couple of these in there. Then we're going to do some practice today and you can get an idea. And we're going to mix kind of all the rules all together. Gives you a bit of a delay. Come on. You got this. I can do hard things and you can do hard things. All right, how about step a little bit harder. What if I do, let's do A, B, C. Put those letters. A to the 5th and B to the, let's say, B squared. B squared is hip with B squared. C to the, let's say, negative 3. But let's take it one step farther and let's turn it into a division problem. Go ahead and get rid of this over here now so we have a little bit more space to work. This will be our last one. I'll send you off to go do some practice. Let's divide that. Let's also get our A and our B. Missing my touch screen for sure with this lesson. My A, B, C, and let's make it, let's say, 3, 5, and 4. Right? So let's do this. So this is division, right? So it's division. So just like we did before, we're going to take one letter at a time. One letter at a time. So if I just did the A's, the A would be 5 minus 3, right? Because when you divide, you subtract. So I'm going to subtract 5 minus 3, and I'm going to get A squared. Right? Now what about the B's? If I take the B's, when you divide, you subtract, it's 2 minus 5, and 2 minus 5 is going to be negative 3. This is what we did before, so this is not a new piece at all. Then we're going to add the new piece. Now the C's can be negative 3 minus 4, and it's going to be negative 7. So that's what we would have gotten up until today. But today we're going to add this new piece where we're not allowed to have negative exponents. Everything has to be positive. Wouldn't that be nice if we could just make everything positive? That'd be nice. So the a is positive, so we're going to keep that as a numerator. That's going to go here. The b is negative, so it can't stay as a numerator. It needs to move to the denominator. So if it's negative as a numerator, it's positive as a denominator. And the c, where is it going to go? It's going to go up or go down? Numerator, denominator, it's going to go denominator. So we write c to the 7 here. So our answer for this one would be a squared divided by b cubed times c to the 7th. All right, what questions do you have? Make sure you hop into a live class. If you have questions, message me, do the practice, check the answer keys. You can do this. I'm cheering for you. All right, go do the practice.